A signature move of all Starship rockets are the horizontal to vertical flip maneuver and then land. Ever wondered why SpaceX used the horizontal then flip landing maneuver for Starship rather than landing vertical like they do with the very high success rate with the Falcon 9S? What's the point of trying to do this difficult move thing when they have mastered the plain vertical landing? In this video, we break down the reasons of why SpaceX is doing so. If you're in a car on the highway, open the window and put your hand into the airstream. First, put it sideways, then your palm into the wind. Try different positions. You will notice the force the wind applies on your hand grows linearly with the surface area you expose. So, the more area an object exposes against wind, the more forces it faces. This force is called air friction on air drag. The more air drag a free-falling object faces against its falling direction, the lower will be its terminal velocity. When a Falcon 9 does a traditional vertical landing, it exposes much less surface area compared to a Starship falling on its belly. So, by falling on its belly, a Starship rocket has a lower terminal velocity. It slows down more easily, and slowing down really helps in landing. By the way, if you like our content, then show us some love, and remember to subscribe to our channel FutureFile to watch more fascinating videos about such fascinating futuristic tech. You have to remember that Starship will be traveling a lot faster than the Falcon 9 or Super Heavy booster. This is because it has reached orbital velocity, which the boosters never do. As such, it needs to slow down a lot. Now, Starship could, in theory anyway, perform a deorbit burn over the landing site and slow down with more fuel-burning thrust in the atmosphere and land much like Falcon 9. But the sooner you start the flip and burn, the more propellant and oxidizer you need. This means you have to have carried more along the whole journey with you, which means you had less payload weight available. Every kilogram of propellant or oxidizer on the Starship stage is a kilogram less payload. The earlier plan would require a massive amount of fuel. So instead, SpaceX wants to use the Starship's air drag in the atmosphere to do most of this slowing, save fuel, and carry more payload instead. The other reason is when re-entering. Remember, the Falcon 9 never reaches orbit, the second stage does, and the booster pushes its part of the way there and stays suborbital. So, the fastest the booster is coming in is around 8,000 kilometers per hour. When Starship returns from orbit, it'll be going closer to 27,000 kilometers per hour. If it's returning from Mars or the Moon, it'll be even faster. As it hits the atmosphere, it compresses the air in front of it, turning it into very hot plasma. For that maneuver, you want the most stable position and the largest surface area to spread out the heat. If you expose a larger surface to the atmosphere as you re-enter, you spread out the heat over a larger area, therefore less heat per tile. SpaceX sees real potential in this horizontal gliding and then flip maneuvering landing. Ultimately, it is all about the most efficient way to get Starship back while providing the most amount of payload capability. But SpaceX is yet to master this maneuver completely. This main problem with the rapid reorientation prior to landing is it causes fuel to slosh around in the almost empty tanks, making it hard to feed that fuel to the engine reliably. In SN8, this caused lower pressure in methane header tank, causing the rapid unscheduled disassembly. In SN10, they tried to solve this by adding helium pressure in the header tank. So the engine started to consume that helium. This resulted in reducing the thrust and leading to the violent landing. But SpaceX has brought several changes in SN10 to solve this. This flip landing maneuver is a very tricky engineering job, but the way things are progressing, sooner or later, SpaceX will be able to solve this. If they are successful in sticking the landing after this flip maneuver, it will make Starship rockets cost less, carry more payload, and be more heat-resistant. That is the vision behind the flip landing move of Starship. If you like this video, you may also watch the video on SpaceX Raptor engines shown in the